Hi students, today we're going to talk about solving equations with radicals in them. So just a breakdown of the concept. When you're solving a radical equation, you always want your first step to be to isolate the radical on one side of the equation. So when we isolate the radical, we're trying to get the radical completely by itself on one side of the equation so that we can get rid of it. The next step is to raise each side of the equation to the same exponent to eliminate the radical. So in this case, since I have a square root, I would be raising both sides of my equations to square power in order to get rid of that square root. Finally, we solve the resulting equation using techniques we learned previously. In other words, we're always solving using reverse order of operations. So we start with undoing our addition and subtraction and move through that process. So just looking at some very basic problems to start with, if I have the square root of x equals 9 and I want to find out what x equals, since the square root of x is by itself on one side of the equation, I need to undo that square root by squaring both sides of the equation. And that leaves me with x equals 81. For problem number 2, again, I have my square root by itself. So in order to get rid of that square root, I can square both sides of the equation, and that gives me 6x equals 144. From there, I'm solving my remaining equation. In order to undo this multiplication by 6, I need to divide both sides by 6. And when I take 144 divided by 6, I get x equals 24. For this last problem here, in this case I have a cube root, and it's by itself on the left side of the equation. So if I want to cancel out that cube root, instead of taking both sides to the second power, I'm taking both sides to the third power. And that's going to undo this cube root, leaving me with x equals negative 262,144. So negative 262,144 would be my answer. And if you're ever having a hard time deciding if you've done a problem correctly, don't forget that you can always plug your answer in to check. So for this problem, and all problems, remember that our goal is to solve using reverse order of operations, and we also want to isolate the radical. So looking at this problem, the first thing that I can do to isolate my radical is divide both sides by 2, and that gives me the square root of x plus 1 equals 2. Now I can see that my radical is by itself on the left side of the equation, so I've achieved my goal of isolating my radical. That means that my next step is going to be to take both sides of the equation to the second power in order to cancel out that radical. That leaves me with x plus 1 equals 4. And from here, I'm just solving using reverse order of operations. So I'm undoing my addition and subtraction. And that leaves me with my final answer. My last step is always to check my answer and make sure that it works. So I plug my 3 back into the original problem. That gives me 2 times the square root of 4 equals 4. That's 2 times 2 equals 4, which is true, so I've checked my work and I know that I've done it correctly. Alright, taking a look at this example, I don't have a square root this time, I have a cube root. I'm doing the same process though, so I'm still solving my equations using reverse order of operations, and my first step is always going to be to try to isolate the radical. So my radical is not by itself right now, so I need to start by adding 1 to each side. And that leaves me with the cube root of 2x minus 9 equals 3. Now I can see that my cube root, my radical, is by itself on the left side. So I've achieved my goal of isolating my radical. So that means my next step is going to be to undo that cube root. And I do that by taking each side to the third power. That cancels out my cube root and leaves me with 2x minus 9 equals 27. From here, I'm just solving using reverse order of operations. So I'm going to start by undoing my addition and subtraction. And then I'm going to undo my multiplication and division. Alright, once again, my final step here is going to be to check my answer. So I'm going to plug this back in to the original problem. Cube root of 2 times 18 minus 9 minus 1 equals 2. So that's the cube root of 36 minus 9 minus 1 equals 2. Cube root of 27 minus 1 equals 2. The cube root of 27 is 3, so 3 minus 1 equals 2. That is true. So I know that I've done this correctly and my answer is correct. Alright, so you might have noticed that sometimes we get solutions that don't actually work, and the appropriate name for those types of solutions are extraneous solutions. So it's really important on problems like this to always plug your answer back in and check to make sure that it works. I'm going to continue to go over some examples once again. I think that if you pause the video and try this on your own, that is going to be more beneficial for you than just watching the video all the way through. So go ahead and pause, try this problem out, and I'm going to go ahead and go over it. So the first thing I always want to do is isolate my radical. Right now, that has already happened, so my radical is by itself on the right side of the equation. So my first step is going to be to square both sides to undo this square root. And remember that when I'm squaring the left-hand side of the equation here, I have to FOIL because this is a binomial. So that's going to leave me with x squared plus 2x plus 1 equals 7x plus 15. From here, I have a quadratic, and I know that because my largest term here is x squared. So anytime I have a quadratic, I always want to put it in standard form before I can solve it. So I'm going to subtract 7x and subtract 15 from each side of the equation to get this quadratic in standard form. Alright, now I have a quadratic in standard form, and I'm going to solve this using one of my strategies, completing the square, factoring, or the quadratic formula. This time I'm going to factor. I'm thinking about what two numbers add to -5 and multiply to -14. And the two numbers I get are -7 and +2. So now I can rewrite this as x plus 2 times x minus 7. And using my zero product property, I can take each of these, set them equal to 0, and solve, and I get x equals -2 and x equals 7. Now last step here, really important, got to check my answers to make sure that they both work, because there's a good chance that one of these solutions is extraneous. So if I plug in my -2, I have -2 plus 1 equals the square root of 7 times -2 plus 15. So -2 plus 1 gives me -1, and this gives me +1. I know that -1 is not equal to the square root of +1, so x equals -2 is an extraneous solution. Okay, next I'm going to check my x equals 7. If I plug that back in to the original problem, I have 7 plus 1 equals the square root of 7 times 7 plus 15. That's 8 equals the square root of 64, which is true, and that means that x equals 7 is my only solution for this problem. Alright, here's another special situation. I have square roots on both sides of my equation. That means that instead of isolating my square root on each side, I can't do that, so I have to just square each side as is. So I'm going to square both sides, and when I do that, 5 squared gives me 25 times my 4x plus 1. And on the right side, 3 squared gives me 9 times my 10x plus 25. So I'm basically taking that coefficient and I'm squaring it, and then I'm also taking my square root and canceling my square root out with my perfect square. So I still need to distribute this to each side. So on the left side, I have 100x plus 25, and on the right side, I have 90x plus 225. So now I just solve using my normal methods. I'm going to move my negative 90x to the other side, and then I'm going to subtract my 25 from each side, and then I'm going to divide, and I end up with x equals 20. Now I'm going to check my answer, plug it back in, make sure it works. Got 5 times 4 times 20 plus 1 under my square root equals 3 times the square root of 10 times 20 plus 25. Going off the screen there, sorry about that. So that's 5 times the square root of 81 equals 3 times the square root of 225. Well, the square root of 81 is 9, so this is 5 times 9, and the square root of 225 is 15, so that's 3 times 15, and both of those are equal to 45, so I know that I've done this problem correctly, and x equals 20 is my final answer. We have a coefficient on the left side, but we don't on the right side. So on the left side, we're going to have 4 times the quantity x minus 2, and on the right side, these are just going to cancel and leave us with 3x plus 4. So I need to distribute my 4, and I get 4x minus 8 equals 3x plus 4. From here, I'm just going to solve by combining my like terms. And I get x equals 12. Alright, now I'm just going to check that, make sure it works out. So I plug it back into the original. I've got 2 times the square root of 10 equals the square root of 40. Now if you remember, we learned how to simplify our square roots here. So if I make my factor tree with 40, I've got 4 and 10, that's 2 and 2. That means I can pull out a pair of 2's, and I'd be left with 2 square root 10. So I can see that 2 square root 10 and 2 square root 10 are the same thing. I know that I've done this correctly, and x equals 12 is my final answer.